Explain logistic curve. Design of water supply and sanitation scheme is based on the projected population of a particular city, estimated for the design period. Several methods are used for population forecasting. They are arithmetic increase method, geometric increase method, incremental increase method, decreasing rate of growth method, simple graphical method, comparative graphical method, ratio method, logistic curve method. Today we will study logistic curve. What do we mean by logistic curve? If the population of a city is plotted with respect to time, the curve so obtained under normal condition looks like S-shaped curve and is known as logistic curve. As we know, change in population is due to several factors, and some of them are unpredictable. Some are fertility, birth rate, death rate, migration. Depending on these factors, the curve can be further broken down into three parts. Low rate, when the death and migration is exceeding the birth rate and population growth at a lower rate. Increasing rate, when birth rate is dominating over the other two rates and overall rate keeps on increasing. Decreasing rate, in this phase the birth rate is still more than the death and migration, but the difference is decreasing. The logistic equation, sometimes called the Verhulst model or logistic growth curve, is a model of population growth. It was named in 1844-1845 by Pierre-François Verhulst, who studied it in relation to population growth. The initial stage of growth is approximately exponential. Then, as saturation begins, the growth slows, and at maturity, growth stops. The form of logistic equation used for population forecasting is as, where A is and B is. In above A and B, N is the time. The nature of this curve can be described as approximately exponential in initial stage of growth. Then, as saturation begins, the growth slows, and at maturity, growth stops. The point where the growth stops and population stabilizes is known as carrying capacity, denoted by K. The sustainable yield is maximum at the point K2. This is point of inflection. Here slope is equal to 0. Thus we can summarize as